Okay, in lesson 18 and 19, we're talking about like terms, exponents, and evaluating those exponents. Well, let's start with terms. Now, everyone in math class has heard the concept, please combine like terms. Well, that's fine, but, well, what exactly are like terms? Remember, like terms have the same variables in the same form or some equivalent form, so that the terms excluding coefficients represent the same number. Okay, so here's our example. 3EFG plus 5GFE minus 2FGE. Notice that these all have E's, they all have F's, and they all have G's. So these are like terms. All of these terms are like because they all have E's, F's, and G's. Not necessarily in EFG order, but some order of E, F, and G. It should be pointed out the coefficients of the terms and the signs between the terms do not affect the likeness of the terms, just so they have the same letters. Okay. Here, we have an extension of the distributive property, which we should probably point out. Remember that A times quantity B plus C is equal to AB plus AC. But the distributive property is also true in the opposite direction. AB plus AC, notice how both of these terms have an A, so I can sort of take out the A and then just be left with what I was adding together, the B and the C. This is sort of like reverse distribution, or what we call in math class, factoring. Because the A was in both of these terms, I could take it out and put it in the front and multiply by B plus C. So whereas this is a double bump forward, this is more of a double bump backwards. Okay? Now, let's try to combine some like terms. This is from up above, 3EFG plus 5GFE minus 2FGE. Notice they all have the same letters, so we're allowed to put these together. And the way we do that is just by adding or subtracting the coefficients. 3 plus 5 is 8. 8 minus 2 is 6. Well, 6 what? Well, some combination of these letters. So I'm just going to use the first one out here, EFG. And that's our answer. Let's try this one down here, number 1. We have MN, MN, and NM. All three of these terms have N's and M's, and that's it. So we can put them together. 4 plus 4 is 8, minus 2 is 6. M, N. And I guess I should have used lowercase because that was here. Okay, number 2. RST, SRT, TRS. All three have S, R's, and T's. So we can put these together. 9 minus 2 is 7. 7 plus 3 is 10. 10, R, S, T. Let's try one more example, and then you can do the rest on your own, and we'll start with 4, 5, and 6 in class. But let's go ahead and try number 3. 5KL, 2LM, 3LK, 3ML. Well, notice that we have KL and LK. Those go together. 5 plus 3 is 8 KL. And then we have LM and ML. Those go together. So we have 2 plus 3, which is plus 5 ML. KLs and MLs do not go together, so this is as simple as we can get. I'd like you to try 4, 5, and 6, and we'll pick up there in class. But for now, let's go to the back of the front page and talk about exponents. Whenever you have an exponent, there are two parts to that exponent. There's the base, which is the big whole number that sort of sits lower, and then there's the exponent, which is the small number that's up at the top. An exponent is really just another way of telling you how many times to multiply a number by itself. So really, 5 to the 6th is 5 times itself 6 times. It's not 5 times 6, it's 5 times itself 6 times. Okay. Let's talk about powers of negative numbers. In each of the following, 3 is the base. Except out here in number 4, negative 3, I suppose, is the base. Anytime we raise a positive number to a positive power, the result is always positive. So something like 3 squared, that's 9, positive number. 3 to the 3rd, that's 27. 3 to the 4th is 27 times 3, 81. Okay. Now, however, sometimes when you raise a negative number to a power, you can end up with a positive number. And other times, you can raise a negative to a exponent and get a negative number. Here's an instance where negative 3 is always the base. Remember, the exponent just tells you how many times to multiply the number by itself. Well, if I'm multiplying negative 3 by itself twice, that's a negative times a negative. That's going to leave me with a positive 9. Similarly, down here, with negative 3 to the 4th, that's a negative times a negative times a negative times a negative. 4 negatives. That's going to leave me with a positive 81. Similar to what we got up here for 3 to the 4th. Here's where the difference comes in. When the exponent is odd. Because you'll have negative times a negative, they'll cancel, but then you'll have 1 left over to bring that back to negative. So whereas 3 to the 3rd was 27, negative 3 to the 3rd is negative 27. Now here's an instance out here where we have a negative to an even power. That's going to give me a positive number. But there's an extra negative sign out here. That's going to turn it back positive. Remember, negative 3 to the 4th was 81. But with that extra negative sign out here, that turns me back negative. Okay, let's try some simplifications down here. Now, we really have to be careful with our notation here. Right here, we have negative 3 to the 3rd. And notice how I put a pause in between the negative and the 3 to the 3rd. This means the opposite of whatever 3 to the 3rd is. So we're going to take 3 to the 3rd, and we know 3 to the 3rd is 27, and tack on a negative sign out front. Minus this guy right here. This says negative 3 squared, or to the 2nd. Notice where the pause is, and notice how it's different from the pause I put in up here. This says negative 3 to the 3rd. This says negative 3 to the 2nd. Notice where the pause is and how it's different. Negative 3 is getting squared, or to the 2nd power. But over here, positive 3 was getting taken to the 3rd power, and the negative sign was getting put on at the end. This is negative 3 times negative 3, which is positive 9. Same idea here. Negative 2 squared, positive 4. Negative 27 minus 9, that's a negative 36, plus 4, final answer, negative 32. All we did there was just add our numbers together whenever we were finished. Okay, now, long simplification here. Let's see if we can get through it. Negative 2 squared. That's 2 squared is 4. Tack on the negative sign. Minus, please don't multiply 4 times negative 3. We have to do the exponent first. Remember, please excuse my dear Aunt Sally. Parentheses, then exponents, then multiplication. So negative 3 to the 3rd brings me to negative 27. Negative 27 times 4, 108. Same idea here. Minus negative 2 squared, that's 4. 4 times 2 is 8. And then minus 2 at the end. So here we go. Negative 4 minus 108. Negative 4 minus 108 is negative 112, negative 120, negative 122. Negative 122. Let me look at this and make sure I got my sign right here. This should have been a negative coming out of here. So this actually all should have been negative. This number. See? This is why we have to be careful to put our numbers in parentheses so that we don't lose negative signs. Because now I'm realizing that negative 122 is not an accurate answer. This should actually say negative 4 minus a negative plus 108 minus 8 minus 2. That looks a little better to me. Negative 4 plus 108 is positive 104. Minus 8 is 96. 96 minus 2 is positive 94. There we go. Okay, that looks a little better to me. Okay, make sure you continue with part 2 to wrap up this lesson, 18 and 19. Back there, we will do evaluations of exponents.